Hey, it's Tony from Adafruit, and in this video I wanted to look at something kind of interesting with MicroPython and a way to edit and run MicroPython code using Jupyter notebooks. So Jupyter is a really neat Python tool that lets you run Python in a browser, not necessarily running Python, but at least interact with Python in a browser. And it's usually used in scientific computing for doing all kinds of interesting analysis, but it is just a generic backend for running code, and that code might be on your computer in a Python process, or it could be on a MicroPython board, which we'll look at. So I'll show you how I did a quick little extension to Jupyter to connect to a MicroPython board and run MicroPython code and give you the results back in your browser. So it's kind of a cool thing. It's very experimental. I'm not completely sure that I've implemented the kernel correctly, but it seems to work, so we'll try it out and see how it goes. And this could be just an interesting way to play with MicroPython and maybe even do like different tutorials and at least do some learning and guides and things with it. So let's dive in. I'll show you what I've got going. Let's go to the main view real fast. So real quick, so I'll go over what is Jupyter real fast. Actually, I did a whole video on Jupyter quite a few months ago, and if I remember, I'll put a link in the description below when this goes up on YouTube to look at that. But real quickly, at a high level, go to jupyter.org, and this used to be called IPython, I as in the capital letter I, and it was originally, like I said, a Python tool, mostly used for doing data analysis. And it's really cool. It's maybe easier to just show you what it is rather than explain it. So this is Jupyter running right here. And it has a concept of, this is the web notebook. And think of it just like a notebook that you would write down notes in as you're maybe running experiments. You know, you try something, you see what happens, you write down how it worked, you maybe work out some equations in math. This is the same concept but applied to programming. So your notebook here is in your web browser, but this is actually connected to a Python process that's running on my computer. So I can run Python code. I can type Python code into this notebook like hello world, and then when I press shift and enter, it will actually execute. I could actually put multiple lines in here, you know, line 2 if I want, something like that. I could write an entire Python program inside of here, and it's even more advanced. You can load external scripts. There's all kinds of cool stuff you can do. But if I press shift and enter, it's going to run these two commands in that Python process that's kind of hidden from me. Now the process, it's not running in the browser, it's actually running on my computer because Jupyter is actually like a little server that I'm running on my computer. But it is nice that I'm interacting with this in my browser, and so it just ran that Python code in this little Python process and kind of took the results and gave them back to me so that I can see them here. And it keeps track of what I just ran. So like if I make a variable, you know, foo equals hello world foo, and I run that, then I can actually print out the value of foo. This is just like if you're at the Python prompt kind of interactively. So it's showing me the output of that thing. If I wanted to run something just to show you that that variable exists, you know, hey, look, you've got that value there. So I wanted to see if I could have this same concept, you know, use this interesting web UI right here, but connected to a MicroPython board, like right here. This is an ESP8266 that's running MicroPython, so that when I type in code right here in my notebook, it goes and runs it on this board, gets the results and sends it back, and then shows me in the web browser what happened on my MicroPython board here, because this could be kind of cool. It could be neat. You can make different notebooks like this, and this could be a good way to maybe teach someone how to use MicroPython. I can make a notebook that explains, you know, here's how you create a GPIO pin, and here's how you toggle it on and off, and here's how you read its value, or things like that. So it'd be kind of cool. And you would have the code embedded in the notebook here, and then you'd have a connection to your board, and so you could just run that code and see what happens. So I dug a little bit into Jupyter to see how this works, and so the Jupyter homepage here has all kinds of good details on what's happening here. And like I said, it used to be called IPython because it was only a Python implementation, so when you created a notebook like this, you could only write Python code. But they realized this is much more powerful and should work with languages beyond Python, and so in the last few years, they've renamed it into this Jupyter project to get away from the concept of it only being with Python, and you can actually plug in what they call kernels, which are just other language implementations. And so there's all kinds of kernels for, I would bet probably every major programming language has one kernel by now, but for sure the major data processing, the scientific computing kernels, things like R and Julia, some of these languages that you use for like statistics and things, you can plug in and so you can write that code inside of these notebooks and create these really interesting data analyses that are stored in these notebooks. But the cool thing is, based on that extensibility, I could plug in anything, like any language, like MicroPython, and even a concept of a connection to an external board. So if you dig into the documentation here, it actually talks about how to make your own kernel. And there are basically two things, and I'm not an expert on this, so I'm not going to really try to explain this. But from what I understand, what's really happening with Jupyter behind the scenes, like I said, what I see right here is a web interface. This is all JavaScript running in the browser, but it's talking to a little server that's running on my machine right here. It's actually running in the background right here, the Jupyter Notebook server. And that server is running that Python process. And so whenever the web browser here has a new set of code, like this set of code, and I want it to run that code, it actually sends that code to the Python process that's running right here, runs it, gets the result back, and sends it back to my web browser. And it uses like 0MQ and all of this advanced messaging stuff to do that, which is really cool. But the nice thing is there are two ways to implement a kernel. So you can do it at the lowest level, where you manually send and receive those 0MQ messages. So that's good if you're plugging in some brand new language and you just need that low-level control. Or if you're plugging in something that can run from Python code, they've done most of the hard work for you, and they have this simple Python wrapper kernel that basically you can take a default kernel implementation that does all that 0MQ junk for you, and you just fill in a few functions that say, hey, when I want to run code, here's how I talk to my board, and here's how I send the code, and here's how I get the results back. And then this, the wrapper will take care of all that communication between the web page and your actual Python code here. So that's really all I need to add MicroPython integration. You know, I can plug in a serial connection to this MicroPython board, run the code, because, you know, with MicroPython, I have the REPL for this board. So for example, I can show you if I connect to my board's REPLs, this ESP8266 right here, you know, this is just a serial port. So this, on my machine, it happens to look like this Scilab's serial port, but I'm in this Python REPL right here. So, you know, if I can connect to this programmatically, send it code like, you know, print hello world on my MicroPython board, and then if I can get this result back and send it back to my IPython or my Jupyter notebook front end, then I can probably make this work. And it turns out I did actually get this to work, or at least it works well enough. Like I said, it's the documentation, there's a little bit of stuff that's unclear with creating a custom kernel, but I think I got everything correctly here. So I'll show you real quickly how to set this up and make this work. So I made this Jupyter MicroPython kernel GitHub repository, and I'll put a link in the description when this goes up on YouTube so you can go to this repository. So what you need to do is check this out, and the README explains what has to happen here. And just as a note, this is highly experimental. I'm not completely sure this will work for everyone. So it's, you know, just try it out, and it's fun for experimenting right now. But step one, install Jupyter. So I linked to the installation page. If you're on Windows, this is a little challenging, unfortunately, because Windows is not the easiest environment for Python. They generally recommend using something called Anaconda, which will install Jupyter and all this stuff automatically and just work. So I recommend doing that. But in my case, because I'm on Mac, or if you're on Linux, you can usually install Jupyter just with a pip command, this pip install Jupyter command. That's what I did on my machine right here. If you're on Windows, you can actually make this work, but it's a lot of work to do that, so you probably want to use Anaconda. But just note, if you're using Anaconda, that does matter, because for the next steps, so after you install Jupyter, then you need to clone this GitHub repository right here. So either download it or clone it. You click this download a zip and download the zip file, and then go into the directory. So I'm in that directory right here. And you need to run this setup.py install command, but make sure to run this with the version of Python that Jupyter is installed with. So if you did like a pip3 install Jupyter, like their installation instructions right here recommend, then make sure to run Python 3 setup.py install. because it's a very subtle difference. If you have Python 2 installed, and if you install this kernel in Python 2, but you run Jupyter with Python 3, they're not going to see each other. So same thing if you're using Windows and Anaconda, make sure to open an Anaconda Python terminal, or an Anaconda terminal, I think they give you, that lets you basically just, make sure that you have a terminal open that when you run Python, it's using the version of Python that Anaconda has, and not a separate version that you might have installed for this. So just make sure that you're installing this into the version of Python that has Jupyter. So in this case, you want to run this python setup.py install. So I'll do that in my directory here. In my case, Python 3, because I've installed Jupyter in Python 3. So I'll say setup.py install. This just runs this setup script and installs this kernel. It will also install a dependency, this Python serial port dependency that it needs. And luckily, it should just automatically download that and install it, so you don't need to worry about it. Make sure you see this line here, finish processing, and you don't see any errors. If you see an error, then something went wrong and the rest of this won't work. So you probably need to stop and go back and make sure, do you have Python installed? Do you have Python 3 installed if you're using that, for example? Are you running from Anaconda? All of that, go through the basic stuff and don't continue until this setup completes successfully. Okay, once this is installed, now unfortunately there's no pretty UI for this. So like in Jupyter Notebooks, this is kind of cool. Like once I close out of this, oh, oops, I just halted the whole thing. But I'll come back to this. But there's no UI, unfortunately, in Jupyter Notebooks to let you kind of pick, okay, what's the serial port for my board? What's the baud rate? It won't list all of the boards that are connected to your machine, unfortunately. You kind of have to manually do that. And so I explain in the README here what you have to do. Basically, you have to create a Jupyter kernel specification. And so that's just this JSON formatted configuration file that tells Jupyter, this is my MicroPython kernel that I want to run, and here is the serial port and the baud rate that it will use. So you have to bake that into this kernel configuration. I would love to know if Jupyter folks, see this. Is there an extension mechanism or a way to kind of pass in data to your Jupyter kernels? I don't see any way to do that, unfortunately. And they kind of mentioned the docs and in some of the Google groups that it's just not implemented yet. So maybe in the future there'll be a fancy way to do this. For now, you kind of have to roll up your sleeves a little bit and do some command line magic, or at least edit some files. It's not that hard. So it mentions here, you have to find your Jupyter kernel specification location. And so go to this page right here, and this is the documentation for where these things live. And there are like 3 or 4 different places these things could be located, unfortunately. So you want the user specific location because that's the easiest place to edit these. And this differs based on every platform. So on Windows, it's in this app data location. Now, if you've never used app data, this is actually a hidden folder that's in your C users, your username, and then it's a hidden folder called app data. And then inside of there, it's called roaming. So that's where you want this. But if that's super confusing, I put a link to this page that explains where to find this thing. So it's unfortunate in Windows, they really hide this from you. So it looks like if you open up the start menu and you enter in the %, app data, %, I think they mention it right here, then it should open Explorer to that location, and then you can go into roaming and find this. Well, this is weird. I'm hearing some kind of noise here. I've got, oh, it's this stupid web page. I'm like, what is this thing? It's playing music. This is the best feature in Chrome, mute the tab. So when you have a spammy web page, you can mute all the audio there. I thought I was going crazy there just hearing something. Anyways, so that's the unfortunate thing. On Windows, you've got to track down this hidden app data folder. And then inside of there, you need to create, if it's not already created, a Jupyter folder and then a kernels subfolder. And that kernels subfolder will probably not exist, so you need to make that thing. On Mac, it's in your users library Jupyter kernels folder. So on my Mac right here, I can show you the library Jupyter kernels folder. And so I've got something inside of there because I created this ahead of time. But make sure to create this folder if it doesn't exist. And then on Linux, it mentions it's in this .local share Jupyter kernels folder. So the bottom line is you need to create this kernels folder in the specific location for this kernels file. And then the next step is you need to create a folder inside of there called MicroPython. So in my case, if I list in my library Jupyter kernels location on my Mac, I have a MicroPython folder that I created. And then if I list what's inside of there, there's this kernel.json file. And so it mentions in here, you need to copy the included kernel.json file from this GitHub repository. So I include this kernel.json file right here. So you want to copy this file into that kernels folder inside of a MicroPython subdirectory inside of there. So copy that file over, and then you need to edit that file. So in my case, so I've already copied that file over, and I'm going to edit that file. So I'm going to edit my library, Jupyter kernels, MicroPython kernels.json. And you need to change a couple things. So this is where you set the serial port name and the baud rate. And unfortunately, like I said, there's no way that I saw to like make this a part of the UI or make this easier. You have to specify this way right now. But you can see on the fourth line right here, and this is a JSON formatted file, so be careful that you don't change, like, you don't accidentally get rid of a double quote or get rid of a comma. Make sure to keep all of the format consistent. But if your serial port for your MicroPython board is a different name than this dev tty USB to UART, you probably need to change it so on like Windows, you're probably like COM4, for example, something like that, you would change this to. And then the baud rate, usually for most MicroPython boards, you can keep it the same, 11.5.200, but make sure it's in quotes because it's a JSON thing. And then the last thing is this sixth line right here, the display name. You probably want to change this also if you change the COM port above there. This is just what the Jupyter UI will show in the list of kernel names. So you can put anything here. It just doesn't have to be what your serial port name is, but it probably makes sense to say this is my serial port that this is associated with. Then keep everything else the same inside of here, like the language, MicroPython, all of that. So save this file. I'm not going to save this because I don't want to set COM4. I want to keep the old values I had. But just to recap, so make sure that you have that in your Jupyter's kernels folder, you've created a MicroPython folder, and you've copied over that kernel.json, and you've edited it so that it has the serial port and the baud rate for your kernel inside of there. Once all of that's done, then that's luckily a one-time step. But you do need to do that for each serial port and for each board. And I've not tested. I don't even know if you can have multiple of the same language kernels installed. I think it works. Give it a try. But worst case, you might have to just only have one kernel installed. So like I said, this is all experimental stuff. But maybe we'll figure out what works and what doesn't, and maybe give some feedback to Jupyter folks. Okay, so now that I've done that, so like I said, in the README, I kind of explain, you copy that file over. This explains what you want to edit on that file. And then at that point, you're ready to go. So now let's run the Jupyter notebook. So to do that, this is just like in the Jupyter docs, run Jupyter however you run it. But in my case, I'm going to run the Jupyter notebook command, and that's going to run Jupyter. And so now it's going to look at that kernel location, and it's going to see that I have some new custom kernel that I've installed, and it will hopefully let me create a new notebook that uses that kernel. And the way to tell if that's the case, when you click this new, you should hopefully see your MicroPython kernel inside of here. So that's pretty cool. That tells me that that custom kernel config is working. Now I've connected my board ahead of time. Make sure you've already connected your board before you open this up, because as soon as I create this notebook, it's going to connect to my board and try and talk to MicroPython on there. So let's do that. Let's create a new notebook that's connected to my board, and it says kernel starting, and you just saw that kernel ready just disappeared. So everything is good. It is actually connected to my MicroPython board right now. So it might not feel that way because this is still Python code, but this is cool. So if I run like hello from MicroPython on here, and then again I'll press shift and enter, and that's going to take this code, send it over to my MicroPython board, get the results back, and print them in this little web page here. So I do that, and hey, cool, this is showing hello from MicroPython. And you'll see some debug output, like when I ran the Jupyter Notebook, it's actually doing some debug logging here, so it's actually showing me these are the raw results that it got back from the board. Okay, so now just to prove that this is really the board, let's interact with it. And actually, I'm going to close this notebook, And this is cool. This is actually going to turn off the kernel, so it's going to close that connection. I think I got that stuff right. It should hopefully be closing it. But I'm going to open up a notebook I created ahead of time, and it's using this same kernel. And so this is a little demo, and this is showing off some neat stuff. Like in a Jupyter notebook, you can have a cell that has markdown text inside of here, so you can put in like, you know, paragraphs with explanation and stuff. That's really, really slick what you can do with this. Like I said, this would be a really cool thing to build some notebooks that kind of teach some of the electronic stuff using this. But anyway, so this is connected to my MicroPython kernel that I created before, and as soon as I opened this notebook, it created that kernel, which connected to my board. And so it should be ready to go. So, you know, I can run this hello world. Now it's showing output, but this is actually the output from the last time I ran this notebook. It actually saves that output into your notebook so that you can just see it again. But it's not until I actually go to each cell and manually run it is it going to go back to my board and run it. But this is cool. So, okay, like here is a cell that I created that's going to use this. I just have MicroPython installed. I don't have CircuitPython on this board. So this is using the machine API, and I'm going to create an LED and a button. And this is just using the MicroPython machine API. You can see in the MicroPython docs, this is just using the standard GPIO stuff. So on my case, I have an LED connected to pin 15 and a button connected to pin 13 on this little demo board. So I'm going to press Shift and Enter to run that code. Okay, so that created this LED in this button class. And okay, now the magic moment here. So I'm going to run this line, led.high. This should, on this LED object, tell it to turn on. So when I run this, this will hopefully talk to my board, and we'll see what happens with the LED. So I run this, and hey, check that out. The LED just turned on. So this is definitely showing us that the code that I'm writing on this little web notebook is actually being sent over to my MicroPython board, executed, and then the results are coming back. And this led.high doesn't really return anything, so it's not printing anything out. But that's, you know, pretty cool that it's doing that. So for example, here's a little loop that's going to blink the LED 10 times. And maybe just for fun, let's add like a print to this. So let's say, we'll say print LED, LED on, and then let's say print LED off. So if we look at this loop, I'm just importing the time module. I'm just looping 10 times because you do want to be careful. If I have an infinite loop, IPython and Jupyter, they don't really know when a cell has an infinite loop how it's going to finish. So, you know, I don't want to run a cell that runs forever because it's going to be waiting for that cell to finish, and it's never going to finish. It'll time out eventually after, I think, 30 seconds or so. So, you know, just be aware. This is good for interactive analysis, but it's maybe not so good for like running a long-lived program. But anyway, so this is going to run 10 times. It's going to print out LED on. It's going to set the LED high, so that should turn it on like we see right now. Sleep for a quarter of a second, and then print the LED turns off, set the LED low, which should turn it off, and then sleep for a quarter of a second. So I'll press Shift and Enter to run that, and that's cool. You see it blinking. Now you don't see the output yet because it's still running, and so it waits for the output to finish, and then you can see it collected all of the output and gives it to me here. So this is, you know, the 10 times that it blinked, it's on, off, on, off, on, off. So that's kind of cool. I mean, this would be neat, like if I'm doing maybe data logging with sensors. So if I had like a sensor connected to this board, I could grab a reading, you know, maybe have a loop that grabs like 10 readings and gets them, and then, you know, maybe saves them into a CSV file or something for this. Although that gives me an interesting idea. I haven't done any experimentation here, but I wonder if there's a way to have two different kernels talk and share data, because unfortunately, I can imagine a scenario would be, maybe I want to collect sensor data and then analyze it with Python on my computer right here, like, you know, use matplotlib and all these fancy libraries to graph it. I don't know, that might be an interesting thing to experiment with next and see if you can have, because you couldn't do that right now. You know, all of the Python code I have right here is running on the MicroPython board. So if I wanted to graph something, I can't type Python code here that graphs it out because there's no graphing library in MicroPython. So I would need some way to take that data from the MicroPython board and send it to my computer here and analyze it later. So it's an interesting thing to think about for the future to see if that might be possible. But this is still really cool for just playing with this board and, you know, and interacting with the hardware using this kind of web browser experience here. Okay, and then the last little demo here is just with the button. So this little block of this cell of code is using the button object that I created ahead of time. And the way I wired this up, I have a push button. It's just a momentary push button. One side of it is connected to ground. The other side is connected to input number 13. And then when I initialized it, I told it to use a pull-up resistor. So by default, if this button is not being pressed, the pull-up resistor is going to pull it up to a high value. So the button.value result will be 1. It's going to be true when it's not pressed. And then when I press it, it's going to connect the button to ground. So it's going to connect it to this green wire here that goes to ground. It's going to pull it down to a low value or 0, so that now button.value will be 0. And so basically this if not button.value will be true, and it should say button is pressed. So I'm not pressing the button. I'm going to run this, shift enter, and so I see button is not pressed. Now I'm going to hold the button down, and I'm going to shift enter this block again, and hey, button is pressed. So it detected the button was pressed, and just to be sure, I'm going to run that block again, and button is not pressed. So I press it again, and button is pressed for that. So that's pretty cool that I can read the state of this device and have it shown in this web browser here. So again, just kind of showing that the Python code I type into these cells right here is not run on my computer. It's run on this little MicroPython board that's connected here to this. And so that's pretty much all that I wanted to show with this. Now, I think everything is correct. So in theory, I can restart my Jupyter kernel. So let's try it. Let's see what happens. What this is going to do, it's going to kill the connection to my board, and then it's going to reconnect to the board. And the interesting thing is when it reconnects to the board, it resets the state of the board. So I don't have this LED object anymore created. Like if I try to run this cell, let's see what happens. See, I got an error here. So it actually threw back this error. Hey, LED is not defined. And that's because I didn't run this cell yet. So that's just a good thing to know with these notebooks, is that the state actually depends on the state of your hardware. So this notebook is maybe good to kind of capture here's a flow from start to finish of something I was trying. So when I want to go back and rerun this notebook, I need to start from the top. So I need to remember, okay, let's run this top block right here. Now I can be able to run the next block, which sets my LED high. Then I can run the next block, which blinks the LED, and so forth, and just keep going through this. So, good thing to know that this state is not remembered. When you load the notebook back up, it reconnects to your board and everything is reset for that. But also good to know if you get in a weird state, you can reset the kernel, and that should reset everything on your board as far as the Python state on there. And also, as I showed, if you get something wrong, like if I'm trying to import a library that doesn't exist, it should do the right thing and return back the error that the MicroPython board is sending you. So this is telling me, hey, there's no foo module on this board. So that's all good. If something goes really wrong and an exception is thrown by my kernel code, it's going to reset the kernel and it's going to reconnect to the board. So just an FYI that might happen in that case. But otherwise, that's it. So I think I'll wrap up this stream. If folks have questions, maybe throw them into the chat. But like I said, this is just a little experimental thing I wanted to hack around with. I was thinking earlier, I was wondering, is it possible to connect Jupyter or IPython to MicroPython? And yeah, it turns out it is possible, and it's not a ton of work because it's leveraging this really cool thing that they did. They created this wrapper kernel so that if you can write Python code that talks to something and gets a result back, you can write a Jupyter kernel in a very small amount of code. I guess I'll show real fast the code for this kernel. So it's inside of this kernel.py. It's basically this class right here. Now, there's some funkiness here if you look at this. I'm actually creating a class inside of a function, and that's because, and I explain why right here, it looks like a limitation of kernels. There's no way to pass in your own data to a kernel. Like, I want to be able to tell this kernel, here's your port and here's your baud rate. But there's no way, there's no instance parameters you can pass in. Basically, the Jupyter machinery creates your kernel and it just assumes there's no parameters there, as far as I can tell. So I had to do some funkiness here where I make an instance of a class that bakes in the port and the baud rate there. So it's interesting how it works, but it works. It seems to work. The magic happens in this do execute though, and it's actually really simple because I'm using the pyboard.py file here. So this is this pyboard.py. This comes from the MicroPython source code, and this is the interface. This is the glue logic that connects to the MicroPython board. It uses the Python serial library, and it knows how to put the board into this raw REPL state, how to send commands and get responses back. So that does all the dirty work of talking to the board. And then my code is just telling Jupyter kernel, so it's in this do execute function. This is called whenever a cell in my notebook. So, when I shift enter this cell, it's actually going to call this do execute function, and it's going to pass in the block of code that it wants to run. And so now I tell my Pi board that's connected, I call its execute raw function, I pass it the code that the cell has, and I get back the result and any error that happened. And then I just need to look and see if there was an error, tell Jupyter Notebook, hey, this failed, and here's the error that came back. Or if it succeeded, here's the result that I got back from here. And that's what this little block of code does. And that's it. That's as simple as it needs to be, it looks like, to make this work. And then there's a shutdown function where when I shut down the kernel, I try to be nice and exit the raw REPL and then close the board connection so that, I can reconnect to my board in the serial REPL, and it hopefully won't be stuck in that raw REPL mode anymore. But anyways, that's, real simple, like 50, 60 lines of code right here, it looks like, to get this working. And again, that's because I can run Python code, and so I can use this wrapper that they have. If I couldn't do this in Python code, it would get much more complex, and you'd have to create this 0MQ event handler and like send and receive messages. So luckily I don't have to do that. So it's a little bit simpler in this case. So okay, so I don't see any questions here. Oh, someone was wondering, is the cat coming on? No, the cat, I don't know where she went. She's around somewhere tonight, so she's not here anyways. Oh, someone was saying that Jupyter Notebooks can run in Azure, a machine learning studio. So yeah, there's all kinds of cool stuff. So the Jupyter project, like I said, check out jupyter.org. There is a lot of cool stuff happening in this world. Like I said, it's mostly, it came about for things like data analysis, but that's why I wanted to experiment and see, like, okay, what would it mean and what would it be like to interact with hardware using it? So I think this will be a cool thing to play with. So yeah, there's all kinds of things like I'm sure you can have Jupyter instances that are run on like Amazon or Microsoft Web Services. But the tricky thing is you couldn't use those to talk to your hardware. You have to do this from Jupyter running on your computer because it uses that serial connection to your computer. So if you've got something running on some cloud server, it's not going to be able to talk to your board. So you won't be able to use it to talk to your hardware here in this case. But you could do, if you get a bunch of data from your hardware, you could go send it up to some Microsoft or Amazon cloud and do all kinds of cool processing and stuff on it. For that. So, and Jupyter does have some concept of like a remote kernel. So maybe there's some crazy way to run Jupyter on your machine using your MicroPython kernel, and then have your Jupyter in your cloud connected remotely to your MicroPython kernel. I don't know. Maybe that's possible. That could be an interesting thing to play with later. Like I said, this is basically a proof of concept to see if this would work, and it looks like it does work. So check it out. Like I said, check out in the description below. I'll put a link to this GitHub repository. And right now, this is just a README that explains how to do this. So like I said, you have to install Jupyter. You have to install this little Python package that is in this GitHub repository. And it is experimental, so it's not super polished right now. But anyways, I will wrap up this stream. I'll put it back on the main view here. So thanks a lot for watching. Check out youtube.com/Adafruit. You can see this video and all kinds of other fun project videos. Check out twitch.tv/Adafruit. You can see me stream these things live. I like to do a live stream every Friday, doing all kinds of cool MicroPython and CircuitPython stuff. Check out, I think we just had a new release of CircuitPython today, 0.9.5 if I remember correctly. So like bug fixes and things. Lots of cool stuff happening in the MicroPython world and CircuitPython world. So especially, let's see, where did I put it? I had it here somewhere. I don't think I have it next to me, but check out the last video stream I did. If I remember, I'll put a link in the description on YouTube. So the Feather M0 Express boards are in the shop. And so that is a SAMD21 microprocessor that is tailored specifically for CircuitPython. So it has extra memory, all kinds of cool features. So check that out if you're interested in MicroPython and CircuitPython. We've got all kinds of cool hardware and things in the pipeline coming for that. So anyways, thanks a lot for watching. This is Tony from Adafruit. Click the like or the comment, the subscribe. Let us know that this is interesting stuff, and we'll keep making content like this. So thanks a lot. Until next time, this is Tony from Adafruit. See you later. Bye.